Okay, welcome to my second video in section 7.3 about elastic and inelastic collisions. We're going to look at how we'll solve a inelastic collision problem. Now remember, with inelastic collisions, this is where the two objects after colliding are stuck together. So the key to these is if you see magnet or glue or something that makes them stick together, you know it's an inelastic collision. Okay, so let's go through and, like usual, look at the important information. So in this problem it says a 15 kilogram barrel covered in glue is rolling along at 8.2 meters per second. The barrel runs into a 3.2 kilogram tricycle parked by a tree. How fast is the barrel tricycle combination going after impact? Okay, so all this information that I highlighted is important. Okay, so we'll go into that in a second, but let's go ahead and write out our equation. So for inelastic collisions, the equation is going to be mass 1 times velocity 1 before plus mass 2 times velocity 2 before is equal to the total mass of our two objects multiplied by the velocity of the two objects after the collision. Okay, so something to notice right quickly. The first half is just like the elastic collision problems. Nothing's different there. It's the second half, where we'll see in a second, where things get a little bit different. So now that we have our problem highlighted and our equation written, let's label the stuff in the problem. Okay, so the 15 kilogram barrel is going to be our first object. So mass 1 is going to be right here. So we've got 15 multiplied by the velocity of the first object. So the barrel is going 8.2 meters per second. And that's going to be plus mass 2. The second object is our 3.2 kilogram tricycle. So we've got 3.2 multiplied by the velocity of our second object, our tricycle. And the tricycle is parked. So the velocity there is going to be 0. And that's equal to our total mass. And this is where it's a little bit different. Okay, for the total mass, we have to add up the mass of the first object and the second object. So we have to do 15 plus 3.2, I'll do it over here, 15 plus 3.2 gives us a total mass of 18.2 kilograms, and so I'll put that in green here, 18.2 kilograms multiplied by how fast is the barrel tricycle combination going. That's going to be what we're looking for. We're looking for, and I'll put this in red, well, let's go with black. And this is what we're going to be looking for, the velocity afterward. So just like last time, we have to do some simplifying first. So 15 by 8.2 is going to be 123. 3.2 times 0 is going to be 0. And that's equal to 18.2 multiplied by our variable, the velocity afterward. So doing a little more simplifying, and remember in these videos I try to show as much work as possible. I need to do 123 plus 0 is going to be 123, and that's equal to 18.2 times our velocity afterward. Okay, we're getting close to the end. We're going to now divide both sides by 18.2. Anytime a number is beside another number, you have to divide to get rid of it. So 18.2 divided by 18.2 gets rid of it. And on this side, we've got 123 divided by 8.2. So now, just to simplify it, 123 divided by 8.2, that's going to be 6.76 meters per second. And that is going to be our velocity of the both objects connected after the collision. Okay, so what was different here is the problems are a little bit shorter for inelastic collisions. I think they're a little bit easier. Now, remember, the trick to knowing to use this equation is, are they connected after they crash into each other? And in this one, it was the barrel covered in glue that clued us into them sticking together. And they usually have some sort of like barrel tricycle thing where it basically is hinting that they're stuck together. Okay, so as you're doing these problems, make sure you write down this equation on your show your work answer sheet so you have it handy. And just like last time, make sure if you get stuck on these or have any questions, just let me know. So thank you for watching, and good luck on your problems, and let me know if you need help. Bye.